All right, this lesson, guys, is pyramids and cones. So first, we're going to start with the pyramid. So the formula for the volume of a pyramid follows directly from the volume of a prism. The pyramid will always be 1/3 the volume of the prism with the same base and heights. Prisms are also named by their base shape. So the formula for a pyramid, which is on the reference sheet, is volume equals 1/3 BH. And again, as a reminder, B means the base area. So when you see a capital B, you need to be doing a calculation for that. H is the height of the pyramid. So in a pyramid, the height is always perpendicular from the pyramid's point. Okay, and I'll kind of show that in the pictures. So I have 3 pyramids here for you, and they're named by their base. So this has a base shape of a square. So this is going to be called a square pyramid. This one here has the base shape of a rectangle. So it's a rectangular pyramid. And then this one here, not as common, has the base of a triangle. So it's a triangular pyramid. Okay, so to do the volume of all of these things, we're going to use that formula V equals 1/3 BH. So you can do this one of 2 ways. If you could take the B and kind of do a little side work. The base is a square, so it's 8 times 8, so it's equal to 64. And then here's the height. So it comes from the point straight down, and it's going to go right dead center in whatever the base is. So the height in this one is 10. And then we simply punch in our calculator 1/3 times 64 times 10, and we get 213. This one actually came out to be a repeating decimal, centimeters cubed. Another way that you could write this out, if you don't want to do the base work by itself, you can just kind of put it in here. So the base in this one is a rectangle, so it's going to be 4 times 6, and then the height, which comes straight down, is 8. So you can write it this way, or you can just put it all in the formula. So this one is 64 centimeters cubed. And then lastly, the triangular prism, kind of the trickiest one with the formula, because the capital B, a triangle area is 1/2 base times height. So if you look at the picture, it's 1/2 of 3 times 5. And then the height of the pyramid is 8. So all those put together, this is my capital B for triangle. This is going to get me 20 centimeters cubed. Now, in a pyramid, there's also something called the slant height. So if you kind of take a look at this picture here, this right here, this is the pyramid height right here, okay? This line right here, we call this the slant height. That's going to be on one of the faces, and it'll be perpendicular to one of the sides, okay? So now, if you take the height and the slant height, you can connect them to form a triangle here, which means you may have to use Pythagorean theorem in some pyramid problems. If we were to try to find the height of this pyramid, or I'm sorry, the volume is 1/3 BH. As we start writing, the base is 6 times 6, the base area, but the height is blank right now. So what we're going to do is we're going to do Pythagorean theorem. Since this right here is dead center in the base, it's always going to be half of this distance. So because this is 6, this little part here is 3. So we're going to do h squared plus 3 squared is equal to 5 squared, because they're telling us that this is 5. So we have a right triangle, the hypotenuse is 5, and we have 3 and h for the legs. So we're going to just solve this out. We're going to subtract 3 squared from both sides to get h squared is 16. So the actual height of this triangle is 4. And then I'm going to go over here, and I'm going to put the 4 in so I can calculate the triangle's full volume to be 48 centimeters cubed. Okay, so regular height is from the point straight down. Slant height is this slanted height that's on one of the faces that connects to one of the outer edges of the base. So if you didn't have a picture, for example, for this bottom one here, it says, what is the volume to the nearest hundredth of a cubic centimeter of a right square pyramid with the base edges of 26, so it is a square pyramid, and a slant height of 20. So that means if you were to draw the base of this pyramid, you would draw it as a square, and all the sides would be worth 26. okay? Now, the height will always come straight down. So if we attempt to draw this here, this would be our height. See if I can make this look good at all. So our pyramid would kind of look like this, okay? I'm going to get rid of this 26 so it looks a little bit nicer. So this line right here represents the height, okay? They're telling us that the slant height, the diagonal, is 20. So now remember, this is dead center. If this is 26, this is 13. So our height right here is not known. So I'm going to do Pythagorean theorem. H squared plus 13 squared is equal to 20 squared. And we're going to solve this out. We're going to minus 13 squared over. H squared equals 231. And we'll square root both sides to get 15.2. This is going to be dot, dot, dot. This is going to be a long decimal when you type it in your calculator. And then I'm going to use that. So volume equals 1/3 BH, right? Every time you see a capital V, you need to do a calculation. So this is a square. It's a 26 by 26 square. The height is that 15.2 number. When I put this all in the calculator, I got to make sure I grab that unrounded answer, which we worked on a lot in the trig unit. So it's 3,424.77 centimeters cubed. Okay, so a few practice ones. If you want to find the volume of these, you can pause it and try on your own, or you can just kind of walk through it. So this first one here, volume equals 1/3. The base is a 6 by 6 square, so I'm doing 6 times 6, and the height is 14, which we can see. We type that all in, we get 168 centimeters cubed. Our second one here is a triangular pyramid. So again, the base of a triangle, the area is 1/2 base times height, so that 3 times 9, and then the height of the pyramid itself is 8. We type this all in, and we get 36 centimeters cubed. Lastly, as we go through to do this one here, the volume is 1/3. The base is 8 times 6. The base area is 8 times 6, and the height is missing. So I'm going to just come up here and do my Pythagorean theorem. Height squared plus, so since this is 8, this section right here is worth 4, plus 4 squared is equal to 10 squared. I'm going to subtract the 4 squared over. Whoops, should be a 4. And I'm going to get h squared is equal to 84. I'm going to square root that to get 9.2 dot, dot, dot. So I'm going to bring that unrounded answer in and get a volume of 146.6 centimeters cubed. And one more for pyramids here. The volume of a rectangular pyramid is 64 inches cubed. If the base dimensions are 4 inches and 6 inches, what is the height? So here's our formula, 1/3 BH. We're going to fill in the volume of 64. The base dimensions are 4 times 6, and then we have the height. Best case is to plug this in our calculator together. So if you plug in 1/3 times 4 times 6, it's going to come out to be 8. Sometimes that'll come out to be a nasty decimal. You would have to just leave it as a decimal. And then we're going to divide both sides by 8 and get an answer of 8 for the height. Okay, so moving on to a cone. So at the bottom, here's a cone. The formula for the cone volume follows directly from a cylinder. The cone will always be 1/3 of a cylinder. So, and then again, we're going to use the base as a circle for a cone every time. Cones also have a slant height. They have a regular height, which goes from the tip straight down, and then we have a slant height on the outside here. So the volume of a cone is 1/3 pi r squared h, which is on the reference sheet as well. Okay, couple quick examples with a cone. So because we have pi in there, some of them are going to be nearest tenth, some of them are going to be in terms of pi. So these first ones on the top here are all to the nearest tenth. So volume is 1/3 pi r squared h. So in this first one, r is 3, h is 8. It comes from the point down. When you type this in, you do use the pi symbol in the calculator. You do not put 3.14. And then we round it accordingly, 75 centimeters cubed. The second one, volume is 1/3 pi. In this case, the radius is 6, okay, half of 12, and the height is 4. We punch that all in the calculator, and we get 150.8 centimeters cubed. And then this one over here is another one where the height is missing, so I'm going to do a Pythagorean theorem up here. Height squared plus 5 squared for your radius is equal to 13 squared. I'm going to get rid of that 5 squared, and I'm going to get h squared is equal to 144, so h is equal to 12. Now I can do the volume. 1/3 pi r squared h. 1/3 pi 5 squared 12. Volume is 314.2 centimeters cubed. Okay, the next set is in terms of pi. So what that means is to refresh your memory from when we did cylinders, we're going to put everything down in the formula, 1/3 pi 2 squared times 9. So that just means we do not punch the pi in our calculator. The only thing we type in is 1/3 times 2 squared times 9. If you do that, you get a 12, and then we attach the pi onto the end, centimeters cubed. Same thing for number 2, 1/3 pi, in this case the radius is 9, it's half of the diameter, and the height is 10. We do not type in the pi, we type 1/3 times 9 squared times 10. We get 270, we attach the pi to the end of it, centimeters cubed. Now if you notice in this one, we're actually missing the radius, which can happen. So in this case, it would be 15 squared plus r squared is equal to 17 squared to get our radius. We'll minus 15 squared to the other side to get r squared is equal to 64. So the radius in this one is 8. Volume is 1/3 pi 8 squared times 15. We do not type pi in the calculator. We get 320, and then we attach the pi on the end. So in terms of pi means you don't type it in the calculator, you just attach it on the end. All right, so to finish here, we have some mixed problems. So for this one here, we should be able to find the volume of any of these mixed shapes that we've done so far. So in this one here, you have a cone and a cylinder. So you use the reference sheet. The cone is 1/3 pi r squared h. I'll leave some space. The cylinder is pi r squared h. So we're simply going to do both of them and add them together. So for the cone, we notice that the radius is 3. So it is 1/3 pi 3 squared times 9. In the directions for this one, we're doing it in terms of pi. I do not put the pi in the calculator. I get 72 pi. Then I come down to the cylinder. The cylinder also has a radius of 3, but the height of the cylinder is 8. I type that in. I'm sorry, this is 27. I put 72. This is 27. There we go. This one is 72. Okay, so the cone is 27 pi. The cylinder is 72 pi. That gives us a total of 99 pi centimeters cubed. Okay, this one over here, we have a pyramid and a rectangular prism. So the pyramid formula is 1/3 BH, just did that today, and the rectangular prism is BH, but we know we can use length times width times height. So I'm going to do the prism first. It's 12 times 12 times 5, and I'm going to get 720. Now the pyramid's just a little bit tougher, so you got to understand this is 12, right? We take it from here. This is 12, so it's a square pyramid. So volume equals 1/3, 12 times 12. Then I get stuck with the height, because look at the height is blank, okay? But we do have the slant height is 10, and I do know that this is 6, okay, because it's halfway. So I'll do a little Pythagorean theorem. I'll just do it over here. So height squared plus 6 squared is equal to 10 squared minus 6 squared over height squared is equal to 64. So the height is equal to 8. And then I can just go ahead and sub the 8 up here. This volume is 384, giving us a total of 1,104 centimeters cubed for the whole thing. Okay, last page, just a couple more quick kind of short word problems here. The first one, number 3. So a regular pyramid has a square base, so note square. The perimeter of the base is 36 inches and the height of the pyramid is 10. What is the volume? So this one's a little interesting. I'm going to draw the square base. It does not give us the sides. It just says the perimeter is 36. Since this is a square, all the sides are the same. By definition of perimeter, it means you add up all the sides. Well, if I did that, 1, 2, 3, 4 x's, you would get a perimeter of 36, which means all of these sides of this square are 9. So this is 9, 9, 9, 9. They're all 9. Now I can do the volume. Volume is 1/3 BH for a pyramid. It is a square pyramid, so the base is 9 times 9 because it's the area of the square, and the height is 10. We type that all in our calculator, comes out to be 270 inches cubed. Okay, next, waffle cone. A waffle cone, so it's a cone, can be modeled by a right circular cone with a base diameter of 6. So above that, I'm going to write r equals 3. If the whole diameter is 6, the radius is 3. And the volume is 36 cubic centimeters. What is the number of centimeters in the height of the cone to the nearest tenth? Okay, cone formula is this. 1/3 pi r squared h. We're going to fill in everything we know. Volume is 36. 1/3 pi. Radius is 3. So we just do not know the height. Okay, so what we're going to do is we're going to plug this in our calculator. So this one I'll show for you. I know I didn't show the other ones, but I might as well show one of them at least. So we're going to plug in 1/3 is just 1 divided by 3, or you can use alpha y equals. I'm going to type in pi, and I'm going to type in 3 squared. So I type that in. I get 9.42-ish, right? So I'm just going to put 9.42 height. And then I'm going to divide that by both sides. Oops, 2. So as a refresher, just like we did in trig, we would do 36 divided by, then we have to grab that entire thing, and then we round this answer to the nearest tenth. So it'll be 3.8 inches. Okay, last one. A square pyramid has a height of 8 inches and a volume of 96 inches cubed. What is the length of the side of the base? Okay, so a pyramid is 1/3 BH. They give you the volume of 96. We do not know the capital B because we don't know any of the sides of the base, but then we know the height is 8. Okay, so if I do 1/3 times 8, do this one in here. So 1/3 times 8, I'm going to get 2.66 repeating, so I'm just going to put 2.67 capital B. I'm going to divide both sides by that. So I'm going to get 96 divided by that whole thing is 36. So here's the thing. The capital B is 36, but you have to remember, this means base area, right? So because we have a square, the question is, what are the sides of the square that would give us an area of 36? So we have to square root this to get the sides to be 6. So the sides would have to be 6. 6 times 6 equals 6. So the answer for the last one is 6.